Hello and welcome back to Jijo Speaks, and in this particular video I'm going to look at a systematic way of solving DLR set. I will take a CAT 2022 slot 3 set and help you understand how to solve these things very systematically. In one of the earlier video I talked about syllabus of this DLR. The way in which I look at the sets is one kind of sets could be about this quantitative reasoning questions, where essentially you are using these mathematical principles, and that's sort of one kind. So this could be about numerical skills, even set theory, that is one kind. Second are these data visualization questions, where graphs and chart, that is inherent, your interpretation of the graphs and chart is crucial to answer the question. There could be optimization problem, where you get constraints and stuff, conditions, and you have to figure out effective solutions. There could be logic and arrangements kind of questions, with something that you like doing. I think a lot of people love doing these kind of sets. And there are inference based questions, partial information is given, missing data, and all this, and some combination of all this. Whatever it be, we will have a DLR process. First is to decipher. We need to understand. First is reading comprehension. We have to understand what the test setting asking us to do, what are the information that is provided to us. We'll have to look at the questions, definitely, to identify what is that we got to do, and then we'll figure out a layout, a diagram, wherein we'll capture the information neatly, and then we'll go ahead and solve these questions. That has to be the process. Make it very systematic, no clutter. If you solve it systematically, and I think that DLR is very fascinating and is actually pretty awesome. I think you love solving DLR sets. Currently, for most of you, DLR is a pain. I'm sure that DLR can be absolute fun. So this is a CAT 2022 slot 3 set. This is a set, and there are these 5 questions. Okay, first thing is to decipher, right? So we will look at what the set is. So I'm sure that some of you would be selecting set to solve. When you're reading the set for the first time, read it like you actually want to solve it, right? You just want to go through all the information once, right, and see what the game is. So it says that all the first year students in the computer science department in a university take both the courses, AI and ML. Students from other departments, non-CS students, can also take one of these 2 courses, but not both. So already we see pieces for this game. Imagine we are playing a game like chess. We need to have a board, we have pieces, and then there are rules of engagement. So you've got one piece of the department, which is a computer science department, and which is non-computer science department. And then we have got courses, which is AI, ML, where the computer science kids take both, and AI and ML, they have to do both, and non-computer science either take AI or they take ML, only one, they don't take both. Okay, wonderful. And then it says that students who fail in the course get an F grade, another pass are awarded A, B or C grades depending on their performance. Now we got one more piece. Those are the grades A, B, C and F. Those are the grade, and F is a fail, and then the rest is a pass. And we have got A, B, C is individual grades. The following are some additional facts about the number of students who took these 2 courses this year and the grades they obtained. Wonderful. There are 8 of these. We could just quickly read it. The number of non-CS students who took A and ML were in the ratio 2:5. So immediately we see that a little bit of maths is involved. Ratio, I think these numbers are cute. No problem. 2:5 is something that we can deal with. And this is something that is specific to one particular department. The number of non-CS students who took either A or ML was equal to the number of CS students. So now there is one department data. We can use that to put some value to another department. The number of non-CS students who failed in 2 courses were the same as the total number of CS students who got a C grade in ML. Okay, specific to department. When we have got grades involved, so now we have got number 3 is giving grade in both the courses. Now this is combined for both the departments together. My goodness, what's going on? 50% of the students who passed got a B grade, but while the number of students who got A and C grades were the same for AI, they were in the ratio 3:2 for ML. So something that is combining both the courses together, both the departments. Sorry, information that is given. No CS students failed in AI, but non-CS students got no non-CS students got A grade in AI. Wonderful. Another fact about department and how many have failed and grades again. The number of CS students who got ABC grades respectively in AI when the ratio 3 is to 5 is to 2, where ML in the ratio 4 is to 5 is to 2. Again, specific to these individual departments. This particular department and the stuff about grade. The ratio of total number of non-CS students failing in one or two courses, one of the two courses, to the CS students failing in one of the two courses was in the ratio 3 is to 1. 30 students fail in ML. This is for both the courses. Okay, what I actually see is that I can see these grades here. So fail, grade, that data is here. The past, the grade, that is also in 4. You've got grades again in 5. Fail means that is an F grade. And you've got ABC grade. Again failing, this is grade. Grade, I think that 2, 3, 4, 5, 6, 7, and 8, everything is talking about grades. So we'll have to eventually figure out values for A, B, C, and F. And these two is talking about the number of students. Interesting. Alright, so it's fine. So all we got to do is do a little bit of maths. And I look at this math here. It's like what? We have got 2 is to 5, which is okay. We have got what? 50%, cute number. 3 is to 2. And 4 is to 5 is to 2. 3 is to 5 is to 2. 3 is to 1. 30. These are all cute numbers. I don't think that the calculation is going to be huge. But we have to be careful. Alright. So let's go and look at the questions. We have to identify what we got to do. A lot of information is also there in the question. For instance, the first information that I see is these value, which is how many. Alright, and none of these answer choices cannot be determined, or either A or B. That is very interesting. What does it tell me? Is that if we crack this game, we can answer all these 5 questions. There is a flip side. If we make even one mistake somewhere, oh, life is over. It is over, right? So we have to be careful, right? Nothing to hurry, because I don't have to do any additional work in the questions. Sometimes you get questions with additional condition, if and then something is given, which means we have to take one question, solve again, take the question number 2, solve again. We don't have to do it here, which means all I got to do is crack this and we'll get answers to this. And if I look at this is talking about how many students took AI. That is sort of the overall game. And then you look at failed, A grade in AI, how non-CS students, B grade in ML, which means we have to find out how many students have got these grades. Right, this is good, this is great. So all you got to be is systematic, we identified. Now you have to think about a layout. How do we think about the layout? Let's go to the question, think about a layout. Okay, great. So we got to eventually there are 2 departments, 2 courses, 4 grades. Oh, wonderful. So let's start with department number 1, CS, and department number 2, non-CS. I'm just going to put CSN across. And there are these courses, AI and ML. And each of these courses has got 4 grades, A, B, C, F, and let's look at a total. A, B, C, F, and total. So I'll write here A, B, C, F, and the total. Okay, that'll be for this. And for the non-CS, A, B, C, F, and the total. A, B, C, F, and total. And that will be the grade here. A, B, C, F, and the total. And we have got AI and ML. One thing that I also realized is this, that here we're going to do 2 is to 5. We have got this 2 is to 5 here. Say we have got this 2 is to 5. Then we have got 3 is to 2, and 4 is to 5 is to 2, and 3 is to 1, which means that I will be using a lot of variables, probably 2x, 5x, 3y, 2y. I'm going to use variables. So I'll probably, which means that if I start writing variables here, let's say 2y here, and eventually when I got the value of y, then I have to cut it again and write value. It'll be kitchity. We don't like this. So what I'll simply do is, this is where this particular board here that you can see here, I'm going to call as my working board, and I'll also create another board, which this is just to ensure that nothing is cluttered. AI, ML, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A, B, C, F, and the total. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A, B, C, F, and the total. And I've got AI and ML. Okay, the reason why I'm putting it, I will put all the variables on top, and if I get a number, I'll get a number here. Okay, now one more thing is that I don't want to know, I don't know how many of the work I have to do. Should I have to do the complete work? I have no idea. But let's look at the questions. How many students took AI? How many students took AI would mean that we need to get the value of this plus this. Okay, so if I get those two values, I think that we'll get question number 1. So question number 1 requires these two values. Question number 2 says how many CS students failed in ML. How many CL students failed in ML? I need to get that value. That is wonderful. What else? How many non-CS students got a grade A in ML? So that is that particular value. How many students got A grade in AI? How many students got A grade in AI? Which means I need to have this value and this value. Then I'll know that value. That'll be the total. Okay. And the next one is how many non-CS students got grade B in ML. Grade B in ML. So those sort of are the important sort of block. If we get these, we will get something. Okay. So that's good. And then we also have these 8 of them. I'm just going to write here 1, 2, 3, 4, 5, 6, 7, and 8. The reason why I'm writing it, sometimes what you'll do is that, okay, if I have looked at, let's say, condition number 1, I'll cross it. Sometimes we'll skip a condition and say that I'll come back to it later. So I want to know what condition I'm doing. So imagine you're staring at your the piece of paper and then looking at the screen, right? So we have to be systematic. Very systematic. Okay. Let's start this. I also have one more thing. Calculator. I know. Don't judge me. Okay. See, I'm going to use calculator for this. In the examination though, there's a caveat. There is a on-screen calculator. But the problem is your test centers is going to be some college, their lab. You're trusting their system, and sometimes the mouse is crazy. I remember once I clicked on the number 4 in the calculator, it came as 44444. I said, what is this? So ideally that you should avoid using calculators, right? But I'm going to use it. Okay. So let's start with each one. We've got these pieces. This is important data that is here. So one data is that in the CS, take both AI and ML, and non-CS, take one of these courses. So that's important information. So they have to take both AI and ML. This is they have to take either AI or ML, one of them. Okay, that's all we know. Okay, great. All right, the number of non-CS students who took AI and ML are in the ratio 2:5. These are non-CS students. Okay, 2:5. So this is non-CS. They are in the ratio 2:5. Let's write 2x and 5x. See, I wrote 2x and 5x. I don't have to bother. If I find the number, I'll put the number here. Right, so which means first is done. So a little bit of information. The total is 7x. So which means the total number of students of non-CX is 7x. Though that data is something that we don't need. Now no question is asking us to do that data, but we'll keep it. All right. Nothing else. No other inference need to be drawn. So one is done. The number of non-CS students who took either AI or ML was equal to the number of CS students. What does that mean? I think this is reading comprehension, nothing else. Number of non-CS students took either AI or ML. Number of students who took either AI or ML is simply but this number, which is 7x. That's either AI or ML, that is number is equal to the number of CS students. So which means this 7x is also the number of CS students. That number is equal. Then for after everything, we have to look at any additional inference that we can draw. We can draw an inference because we know that these students have to take AI and ML. That means the number of students who've taken AI would be 7x. Number of students who've taken ML will also be 7x because they are forced to take both. They are computer science students. They have to. Okay, story is good. So far, story is good. 2 is done. 2 is done. Okay, so we just need to get this number and this number. I think that we'll get the answer. 7x plus 2x is 9x. Is there a multiple of 9? Okay, this goes. All right. Okay. this one 210. Is it divisible by 9? I don't think it's divisible by 9. This is 90. 90 seems to be too less. It's probably going to be 270. So if it is 270, if 9x equal to 270, x will be equal to 30. Okay, that is one case. We've got one more data. Is 90. All right. Is if 9x will be equal to 90, x will be equal to 10. These are the only two possibilities. I think it's gone. I think sometimes the question also gives us some data. We should not miss it from the question. Question is giving us data, and you can total number of students who took AI is, if it is 90. I'm already seeing some problems here. Then how many students got A grade in AI? It's 42, 99, 84, 63. That is too much. But I think if the total itself is 90, you will not get these values. It's very likely it's going to be 270. It's logically, you know. So imagine, for example, the answer is 42, which means this plus this is going to be equal to 42. This is so. All right. Okay. Anyway, let's keep it at this point in time. I'm basically guessing at this point in time it could be likely going to be 270. But who knows? Who knows? Let's carry on. Let's carry on. We go to 3. The number of non-CS students who failed in 2 courses were the same. Okay. Number of people who failed in both the courses were same. Where am I? Failed in 2 courses are the same. So let's call this y and y. No problem. Courses are the same, and their total is going to be equal to 2y is equal to the number of CS students who got a C grade in ML. Number of CS students who got a C grade in ML. Okay, 2y. Are you tempted to just put this value? I think life will be over immediately. We'll get. Let's see. Okay. So we have nailed 3 as well. No problem. Let's go to 4. In both the courses, this is going to be painful. Okay. In both the courses, 50% of the students who passed got a B grade. But while the number of students who got A and C grades were the same for AI, they were in the ratio 3:2. So this is talking about both the courses. I think that we'll keep 4 aside. We'll have got individual courses, probably come back later. So we'll hope that 4, I'll keep you. Just hold on. Let's go to 5. No CS student failed in AI. They were studs. While no non-CS students got an A grade in AI. Okay. No CS student failed in AI. So this is 0. And this is also 0. Which means this is 0. This is also 0. Okay, which is good. So, which is great. I think there is a question that is asking how many CS students, where is it? How many students got A grade in AI? That means this plus this. Very interesting. All right. So, we're almost there. We are there. Okay, so we got 5 is out. Let's go to 6. The number of CS students who got A, B, C grades respectively in AI were in the ratio 3:5:2. Okay. ABC, 3:5:2. Let's do. We have got Y. We have got. I don't want to write Z. Sometimes you know what the problem with my Z is. Z and my 2 looks the same. Okay, so I avoid Z. Okay, the personal choice. You avoid certain things because you'll get into trouble. You'll get into problems. So we got 3:5:2. We'll do 3P, 5P, 2P. Oh, shall we just? Okay. All right. Okay. All right. No problem. And ML is in the ratio 4:5:2. ABC. We already got a 2y. So there will be 4y and 5y. Wonderful. Don't worry. We'll knock this off. Okay. So which means we have dealt with number 6 as well. Let's go to 7. The ratio of total number of non-CS students failing in one of the two courses to the number of CS students failing. I think this will be easy. 30 students failed in ML. Let's first deal with that. 30 students failed in ML. The failed here, we don't know. This is y. So this will be 30 minus y. Wonderful. So it's okay. We have got 8. Let's go back and look at the 7. The ratio of total number of non-CS students failing in any one of the two courses. The total number of non-CS students failing any one of the two courses, which would be this y plus y, 2y, right? So that is 2y. So let's put it here. Working 2y. 2. The number of CS students failing in one of the two courses. Failing in one of the two courses, which is just this 30 minus y. There's no failure. 30 minus y. This is in the ratio 3:1. This is the ratio 3:1. I think we can do some cross multiplication. I think we have done in school. So 2y would be equal to what? 90 minus 3y. This will become 5y equal to 90. And y is equal to 18. And we have got the story. Y is equal to 18. We'll get this. We'll get this. We'll get this. We'll get this. That means we'll get this. We'll get this. Oh, we'll get this. We'll get this. We'll get this. We'll get this. And then we'll get this. Yeah. Okay. We still have to deal with 4. We'll still have to deal with 4. We'll deal with 4 later, but at least we can get some marks out of this. Okay, so we can have done this. Okay, let's do. So y is equal to 18. This is going to be 18. Okay, so that's wonderful. 18. So this is what? 30 minus y. 30 minus 18 is 12. We got something. What is f? Number of students who failed. What is it? We got some value, 12. We'll deal with it. Let's fill that thing. So this is this is 4y. 4 into 18 is 72. 5 into 18 is 90. And 2 into 18 is 36. Now we have to add these things together. Don't judge me. See, please don't judge me here. 72 plus 90 plus 36 plus 12. Somebody is saying this, sir, what is this? 210. There you go. 210, which means this is also 210. So which means this has to be 270. Correct. This is not going to be this. Okay. So 270 means x has to be equal to 30, which is true. Right, which means 210 times x is equal to 30. So x is equal to 30, this is 210. X is equal to 30. 30 times 2 is 60, and this will be 90. Right, sorry, 30 times 5, 150. Don't make these stupid mistakes. If these kind of mistakes you made is when the life is over. 5 times x equal to 30. Great, and we'll get these value. 3 plus 5 plus 2 is how much? 10. 10 corresponds to 210. So P has to correspond to 21. So 21 times 3, 63. 21 times 5, 105. 21 times 2, 42. And this is where you check and you hope. This is the time when you say, will I get to 210? If we get to 210, we'll be amazing. This is nice. We're already there. 42 equals to 210. We answered a lot of questions, did we? Let's go one by one. This is 270 because how many students took AI? The number of students took AI is 210 plus 60. That is 270. How many CS students failed in ML? How many CS students failed in ML? We can see it. That is a 12. That's a 12. So we can get that value. That is a 12. How many non-CS students got A grade in ML? Which means we have to do this 4. which will do, no problem. How many students got A grade in AI? A grade in AI is 63 and a 0. 63 plus 0 has to be equal to 63, which will be this marks. And then how many non-CS students got B grade in ML, which will be that. So at this point in time, you can probably say, sir, we did this much. Should we actually fight this? Hana? We could just move on. But other people say that I have put in so much effort, I've reached till here, why don't I crack that story as well? So let's go to 4 to get the remaining 6 marks. We'll probably get it in both the courses. 50% of the students who passed got a B grade. In both the courses, 50% of students who passed got B grade. Alright, let's look at how many passed. 210 minus 12, 115 minus 18, or simply we can look at this as well. 210 plus 150, that looks like a 360. 360 minus that'll be 30. 360 minus 30 is 330. So 330 people have passed. 50% of them got grade B. Half of 330 would be how much? 165. Half. We have got 90. So 165 minus 95. Let's use finger. 10, 11, 12, 13, 14, 15, 16, 75. We should not be doing this in the examination. You should know how to solve these questions. 75. We got B to be 75. I think we got one more. B grade 75. Thank you. Now we have to got A. We have to get to A. We'll get to A. We will reach there. Where are we? Why am I shouting and screaming? You might be wondering, what is this guy doing? Chup chap solve karna yaar. Why are you getting really excited solving DLR? Sorry, yeah. Okay. While the number of students who got A and C grades, while the number of students who got A and C grade were same for AI. We don't care about AI. Do we need AI? Let's forget AI. There is no need for this. The only thing that we want to find out is ML. So unnecessary, why should we calculate these two things? There's no need. Let's ignore this. And they were in the ratio 3:2. Okay. No problem. The total in both the courses, the number of students, ML, the total students who got who got grade A and C. So basically that tells me in ML, the total of A and C, they are in the ratio 3:1. I think we can find the total of A and C. What is the total of A and C? This is A here. This is my C here. This is my A here and this is my C here. But I can find the total. How can I find the total? All we need to do is from here, remove this. Whatever remains will be the sum of A and C. This will be a sum of A and C. We can do this with a little bit of maths. Where is my calculator? But don't judge me. 150 minus this 75, which will be 75. Why are you doing this calculation? Minus 18. This is 57. A and C put together is 57. Okay, here it is 72 plus 36. So plus 72 plus 36. 165. The total is 165. They are in the ratio 3:1. 3:2. I was wondering, how is it 3:1? 3:2, that is total is 5. 5 correspond to 165. We are interested in A. Let's forget about C. 5 correspond to 165. So 165 divided by 5. 3:1 multiply by 3. Don't do this calculation. That will be 99. So this plus this equal to 99. This plus this equal to 99. So what is this? 99 minus 72, which I believe is 27. We got that, and that will be the answer to this 27. And there we answered. I think systematic solving. And don't do unnecessary things. I think if you had taken a bet, and this initially when we looked at this number and say that 9x equal to 270, probably these things would have gone faster. So 90 seems to be too less, right? It looked too less. You've got 270 looks better, but it's okay. think all we needed was a multiple of 9. If there was, let's say, if this option, imagine this option would have been 110. Oh, the story would have been over. Because that value must be a multiple of 9. But the question setter did not allow us to do this. That's how we solved. So what did we learn? Basically, at the end of the day, you have to do this very systematically. Now, in the examination, such thing won't happen. You are scribbling things down. You're like, no, chill. And make the decision. One of the things that you remember is that if we crack this story, we will be able to get this. And that is number one. Number two, why? Because all this talking about how many, no additional condition was given. That was number one. Number two, they were asking very, very specific questions. That specific questions were related to just a few things. For example, this was important, this particular value was important, this value was important, this value was important, this is important, this is important, this is important. Once you know which of the values are important, once you got that, you don't have to do unnecessary calculations. There was no need to do these calculations. It was not needed. Those calculations was not necessary. Number three, if for whatever is the reason you could not figure out, let's say sort of one question, maybe you could not figure out this to be 27, this logic here, there is no problem. We've solved 3 questions out of this 5, we'll move to the next set. Maybe we'll solve 5 questions out of this, 4 questions out of this 5, we'll move to the next set. There is no necessity that you have to solve every single question. You move and then you can solve this. So that is a process. What is the process of deciphering, identifying, layouting and resolving? And I hope this made sense. If you need more such videos, I can solve a little more of DLR. Maybe you tell me what is the kind of DLR that troubles you. Is it set theory? Is it this problem? Is that problem? Just let me know in the comment box. I'll pick 1 or 2 of these and then create some more solutions. Goodbye. Now we go and study.